Assalamualaikum and hi everyone. We are from Group 4, consists of Nur Hawa binti Muhammad Rizwan, Nur Quratain binti Hamdan, and me, Syed Ahmad Alfa bin Syed Bakar. We are going to present reorder quantities for QR inventory models. So let's get started. Introduction. Controlling stock inventory is a process and a method of total stock management. Tons of analysis efforts are dedicated to stock inventory control over the few decades. Previous research has shown that interval is an uncontrollable variable in which unmet needs usually occur and then continue. Some companies have recognized the importance of response time as a competitive weapon. They use it as a way to differentiate themselves from the market. In some previous studies, the interval was regarded as a given constant or random variable and therefore was not subject to any control. In many wise situations, intervals are often reduced at an additional blooming cost. In random control models beneath continuous review technique, the reorder level R and thus the order quantity graphic symbol are the parameters to be determined optimally. Their best values ought to be obtained iteratively in most cases, but this can be often tedious and inconvenient for management routines. In some cases, an apply offsetting alphabetic character as a result of the economic reorder amount and computing R consequently is employed. These observers may need a substantial worth penalty as a result of Q wasn't obtained through optimum procedures. The matter is restricted. Aspirations for Q and R cannot be obtained. QR inventory model and planned a non-iterative methodology of deciding the best parameters of the models. Their model use numerical approximation rather than iteration. So this is the model's cost function obtained. Moving on from that problem statement, the purpose of their work was to modify the inventory model of Moon and Chow S 1998, continuous review with variable delivery times and partial back orders by blurring the backlog rate, or equivalently sales rate losses. Taken into consideration the case in which the misplaced income charge is handled as the triangular fuzzy number. Through the statistical method for establishing the interval estimation of the lost sales rate, they constructed a new fuzzy number, namely statistic fuzzy number. Investigated the computing schema for the modified continuous review inventory model and developed an algorithm to find the optimal inventory strategy. Methodology. Number 1. Develop a mathematical model for continuous review reorder quantity (RQ) inventory system. Number 2. Discuss the effects of RAM type of demand on an EOQ model for non-instantaneous Webull deteriorating items under time-dependent partial backlogging. And lastly, number 3, consider the management of safety stock in a coordinated single vendor, single buyer supply chain under continuous review and Gaussian lead time demand.
Case study. First, what we do in the case study, we reformulate the cost function based on Article 1. As you can see in the total holding cost component, there are C. Multiplying C in this total holding cost component is not correct since C is a unit item cost. And we don't use unit item cost in the determining inventory holding cost. And the other reason why we need to reformulate cost function is using Q over 2 in the holding cost expression has no significance. It's only help to use the Wilson EOQ model and simplify the computation. Furthermore, you can only use Q over 2 when the demand rate is known to be.
Hello everyone, first let me introduce myself. I am Nur Fatou Amriti Hamdan, will present the results regarding this topic. The researchers assume that the lead time is uncontrollable variable, unmet demand is always backordered, and so on. Then reference paper number 1 studied QR inventory model and proposed a non-iterative method of determining the optimal parameter of their model using numerical approximation rather than iteration. They obtain their model's cost function as shown in the slide at optimal point. Next, for our model, first we compute the economic order quantity EOQ using formula given and get 1 for 1.4. The modulus of gamma known as T, which is D over sigma power of 2, and we got 0.7. Our group got the value of Z over DPR based on approximation by reference paper number 1. Z over DPR is equals to 1.3. After computing EOQ, modulus of gamma, which is T, and Z over DPR, we compute Q, which is reorder quantity, and got 328 units. By adapting Johnston approximations from reference paper number 1, we assume that the gamma distribution from 0.5 to 12, where probability of outstock PR is less than 0.5, which are 0.08. After the calculation using Johnston approximation, we obtain A3, A4, A5, and A6 value is negative 0.68774, negative 1.14906, 0.69763, and negative 0.56308 respectively. Hence, we got reorder level of R value is 276.916 after the calculation. Finally, we determine the old model cost function at optimal point by using the equation given and got 1022.6 for 328 reorder quantity. Next, we are going to use example as old model to enable us assess the performance of new model. Given the continuous review inventory system and let cost per unit item is $15, cost per order is $30, annual demand average is 1000 units, and holding cost is 20%. We compute Q, which is reorder quantity, and R, reorder level, using new model. The computed values of EOQ, which is economic order quantity, modulus of gamma, G, and Z over DPR are the same as the old model. However, after computing Q reorder quantity using the new model, we obtain 388 units, which is greater than the old model, and the probability of stockout is 0.097. For the new model, by adapting Johnston approximation from reference paper number 1, same as the old model, we assume that the gamma distribution from 0.5 to 12, where probability of outstock PR less than 0.5. After the calculation, we got the new probability of outstock, which is 0.097. Okay. Using the Johnston approximation, we obtain the value of A3, A4, A5, and A6 still the same, which is negative 0.68774, negative 1.14906, 0.69763, and negative 0.56308 respectively. However, the difference value of probability of outstock, which is 0.097, give the new value of reorder level R, which is 255.2578. Finally, we determine the new model minimum cost function at optimal point by using the new equation and got $109.112 for 388 reorder quantity at 255 reorder level, which is greater than the old model. Thank you. For flowchart, we need to determine what the purposes of this paper. The previous researchers assumed that the lead time is uncontrollable variable, unmet demand is always pre-ordered, and so on. If it is true, then we need to check the demand rate changes and demand pattern changes. However, if it is false statement, then we need to check was the order placed on time. If no, proceed to check the operator discipline such as miss order and late order. Sometimes the system is too big to handle. However, if the order placed on time, we need to ask, did the order arrive at time? If yes, check the inventory record accuracy. Otherwise, we need to check the lead time changes, lead time accuracy, or supplier problem.
Discussion. For the first one, the discussion that we want to discuss is the cost function, the order quantity, and probability of stock up. In this paper, we revisit the inventory problem by Article 1 and we obtain the correct expression for C, QR, Q, and PR. And then we go to the standard formulated expression. In this paper, we reobtain the standardized expression by Article 1 for Q based on the correct cost function as below instead of this. And then the performance of the new model. As we can see in the result, the new model gives higher optimal order quantity of 388 units against 328 units from Article 1 model at the same reorder level and the optimal cost of the inventory. The new model we got $109.11 compared to $1,032.6 in the same example in the Article 1. And this we can see clearly that the new model gives lower inventory cost with higher optimal order quantity than the model in the Article 1. As a conclusion, we can conclude that the result of this work demonstrate that the reviewer model give lower inventory cost with higher optimal order quantity than the model under review, which is the model in the Article